I'm glad to meet you, ladies and gentlemen. My name is Kiselev Sviatoslav. Today I would like to present you our work, named Luminescence study of potassium, lutetium, phosphorus 2, oxygen 7, doped with praseodymium 3 plus ions under different types of excitation. Praseodymium doped luminescent materials are recently being actively investigated due to demonstration of fast interconfiguration of 5D4F optical transitions. Praseodymium emission in comparison with cerium ions is located in higher energy region and is characterized with shorter lifetime. The search of new scintillating materials is actually a problem of modern researchers. Systems working at high count rate need scintillating materials with improved characteristics in terms of light output and timing. Such systems one can face up in different spheres such as nuclear physics, security, chemistry, medical imaging, etc. Now let me speak about our research. Studied powder was obtained using solid-state reaction via treating and grinding. Then it was attested with X-ray powder diffraction method. Measurements were done applying different techniques: photoluminescence and excitation, X-ray excited luminescence, pulse photoluminescence, and kinetics measurements. First, let me introduce the results of photoluminescence spectroscopy. The broad emission bands with maximum near 290 nm are dominated in spectrum. They correspond to the parity allowed in the configuration of radiative transitions from the flawless excited 4F1 5D1 state to the multiplets of the ground 4F2 electronic configuration of the praseodymium 3 plus ion. With excitation at 5 electron volt, we observe a broad emission band with maximum near 450 nm. We suppose that this band is related to defects in the crystal structure. PL excitation spectra recorded monitoring different emission bands contain broad complex band in the ultraviolet region between 200 and 250 nm corresponding to intercentral transitions. PCR spectra also demonstrate interconfigurational bands in 250 nm region. Insert shows the comparison of light output of studied sample and studied BGO powder made in same conditions. Integral area under operated region of our powder contains about 40% of BGO output. Decay kinetics of 260 nm line show no build-up stage. This indicates a prompt population of praseodymium 3 plus 4F1 levels by host electronic excitations, which is a typically beneficial result of recombinational mechanism for energy transfer. The build-up stage in 430 nm line kinetics may indicate the presence of shallow traps, which act as intermediate trapping centers for thermalized charge carriers. This is approved in thermally stimulated luminescence measurement. Thermoluminescent curve was approximated with peak detection method, which allows to calculate parameters of charge carrier traps. These parameters are energy depth and frequency factor, both of them are presented. To sum up, upon both ultraviolet intercenter and band-to-band excitation with ionizing radiation, the emission spectra of objects are dominated by praseodymium interconfiguration and LFD radiative transitions. Decay kinetics measurements can establish decay time about 90 nanoseconds. Meanwhile, the delayed energy transfer was suggested to originate from retrapping of charge carriers as defect-related traps, whose presence was demonstrated with thermoluminescent measurements. Thank you for your attention. I will be pleased to answer your questions now.